Hi everyone, I'm going to be going over question number 54 from the Chapter 8 bingo problems. Now this problem is kind of interesting because it deals with, we're in Chapter 8, so we're dealing with like momentum, but this question has to do with momentum, but also center of mass, which I find kind of interesting. So it's saying that there's this SUV traveling along this horizontal road. Its mass is 1,200 kilograms and it's going 12 meters per second. Then ahead of it is a car that has mass of 1,800 kilograms and is going 20 meters per second. And then it says the car has a center of mass 40 meters ahead of the center of mass of the SUV. And then what this wants to know, it says part A, it says find the position of the center of mass of the system consisting of the two cars. So the way we do that is through our little handy center of mass equation, which is going to be that the R, which is our position, center of mass, equals, and it's going to be the mass times position of, we'll just say MS for SUV, RS plus MC for car, RC over MS plus MC. And so when we do that, we end up getting that the R center of mass, so the position of the center of mass, is equal to 1,200 times, and RS is just 0 because this is our starting point of this system. So really that's just 0, so that's all canceled out. So I'll just erase it. And then mass of the car, 1,800 kilograms times position, which we know is going to be 40 meters. And then we'll divide that by the masses combined. So it's going to be 1,200 plus 1,800 kilograms. So when we do that, our kilograms will cancel top and bottom, and we'll end up with just a position, which is good. That's what we're looking for. So when we do this in our calculator, we end up with RCM, so our position equals 24 meters. So that means that our center of mass is going to be, if this is half, it's going to be like right here, which makes sense because the center of mass is going to be it's going to be closer to the car with more mass, right? That just makes sense. So that's good. So we know that our RCM equals 24 meters. So now for part B, this question wants to know, it says find the magnitude of the system's total momentum by using the given data. So we know that total momentum, so we'll just say it's going to be P, is going to be MSVS plus MCVC, right? It's just the two momentums of the parts of the system added together. And so when we do that, we get P equal, and we can put a T there for total, I guess, is going to equal, 1,200 times 12 plus 1,800 times 20. When we put that in our calculator, we get that the total momentum of the system is 50,400 kilograms times meters per second. So that's the total momentum of this system. And I don't think we'll need to use that again. No. So we can erase that for part C, which wants to know the speed of the system's center of mass. So the way we'll do that, we'll say the velocity of the center of mass equals, and that's going to be, we're going to do the same thing, kind of like position, but instead of position, we'll do it with velocity, or momentum. So we'll have msvs plus mcvc over ms plus vs. So basically this is the same as part A, but instead of position, we're using velocity. And then we're using that center of mass equation. And so when we plug everything in, we'll get, VCM equals mass, so 1200 times 12 plus 1800 times 20 over 1200 plus 1800. What we end up with is 16.8 meters per second. So that is the speed at that point. Now part D wants to know, it says find the system's total momentum by using the speed of the center of mass. So we know the speed of the center of mass, and we're going to do the same thing as before. So we'll say P, I don't want to say PT sub T again because we already used that, so maybe like a P prime is going to equal, and since we're using the same velocity, it'll be ms plus mc times v sub c. And then we'll plug that in. We'll get P prime is equal to 1200 plus 1800 times 16.8 meters per second. These are kilograms. And that means that our total momentum of the system is actually 50,400 kilograms times meters per second. And the interesting thing is I erased it from part B, but that's actually the same magnitude. So what we've done is we've actually found the system's magnitude two different ways using two different variables, which is really neat. Because before we did it using the given data, which was the mass and the velocity of each individual item. But then we did it in part B, which was just with the velocity at the center of mass, which is really neat because it really does show that that information at that one point is indicative of how you can shrink a whole system down to one point in its center of mass, which I find really interesting. So anyway, that's how we combined the momentum and the center of mass to find all of these different things about this system of these two vehicles traveling down a road. So anyway, I hope you learned something. I hope you enjoyed watching. I'll see you in the next video. Thanks.